Okay, so this is a presentation about a small project that we did as part of the One CGIAR Digital Innovation Initiative. This was a pilot project that we did in collaboration with the Agro Advisory Services Division of the India Met Department, where we basically used machine learning in combination with OpenAI to meet a very specific requirement of the India Met Department, right? Now, just a bit of the context. Uh, we all agree that agriculture and the dependent livelihoods are at climate risk perennially, right? There are global changes like global factors like climate change and global warming. All these are directly or indirectly creating a lot of new risk for agriculture, right? And somewhere in the early 2000s, the idea of using climate information services, right? When I say climate information services, this refers to the activities of recording the weather information through instrumentation or through other means, storing all this data that has been recorded through instruments, and then using some physical models or atmospheric physics models to also do forecasting, right? So there was the idea that, agriculture being so intrinsically linked with weather, what if we start generating some weather forecasts or climate information services specifically for agriculture to mainly aid farmers in their own decision making, right? So that's where this idea of climate information. So just let me just give me a pointer. Yeah. So that's where the idea of climate information services for agriculture came about. Increasingly, people will also refer to this as something called as agro-meteorological advisory services, right? And there's been a lot of scientific literature which says that, high quality agro-advisory services, agro-met advisory services can build the resilience of farmers and agri-food system actors. The proof in the pudding is if you open the countless number of mobile apps for agriculture that are available in an app store or a play store today, you will see majority of those apps will have some sort of a weather forecasting information that is accessible through those apps, right? So that in a way, I think that is proof in the pudding that farmers genuinely use and demand good quality weather forecast or climate information services, right? And then linked to that, between 2016 to 2022, when I was at ICRISAT, I had the opportunity to work on a collaborative project, with another CGR program called CCAS. So there, as part of that particular project, we deployed a tool called the Intelligent Systems Advisory Tool, where we furthered this notion that, farmers don't just demand weather forecasts, but they actually demand weather forecast based agronomic recommendations. This is what we are calling as contextualized agronomic recommendation, right? And our finding as part of that particular project is the uptake of advisory services when rather than just delivering weather forecasts, if farmers are actually given contextualized agronomic recommendations, the impact is much higher, the uptake is much higher amongst farmers. So as we were sort of coming to the end of that particular pilot project, we also started interacting more and more with the India Met Department in early 2018s, right? And this is where I'd like to give you a bit of the context of India Met Department's own work in the space of agro-met advisory services, right? So India Met Department, was one of the earliest national meteorological organizations globally to have recognized the importance of weather and climate products for agronomic advisories, right? So in order to operationalize a system of translating weather forecasts into crop and district specific advisories, India Met Department came up with this program called as District Agro Advisory Services Program, which has been operational since 2008. And as part of this particular program, IMD established what are called as AMFUs, agro-met field units, right? And so if you look at this picture to the right? So this is how India's DAS program basically works, right? So you have India Met Department, which basically generates weather forecasts and also a lot of climate data for all the 717 districts in India, right? Out of the 717 districts in India, there are about 650 districts which are called as agricultural districts. So you have 130 agro-met field units, which cater to about 650 agricultural districts in India. So technically that is one agro-met field unit catering to about 5 districts in India. So these agro-met field units, each of them in India, twice a week on Tuesdays and Fridays, they are supposed to come together and look at the IMD's weather forecast issued for those 5 districts that are under the jurisdiction of a given AMFU. And then they are expected to translate that weather forecast into district and crop specific advisories. Once they generate those district and crop specific advisories, Government of India has numerous channels. They have this program called as M-Kisan. They have a lot of websites. They have a lot of systems where all this information, the district and crop specific advisories, is also disseminated using social media and various other channels. As of 2016, I think this particular system was reaching nearly 40.2 million farmers. But this system is very manual, and there is a huge amount of expenditure that IMD spends on operationalizing this system. In order to take advantage of digital platforms, what IMD did was it launched another platform called AgroDSS in 2019. And this platform was mainly meant to coordinate across the different 130 AMFUs in the country. And then while I was at ICRISAT, I had the opportunity to create an app called Meghdut. And this Meghdut app basically was launched in 2019. It is currently available in over 12 languages, and it is continuously being improved in fact, in 2023, some part of the Digital Innovation Initiative was also used to sort of further improve the AgroDSS platform and the Meghdut app, right? So the Meghdut app basically is a pan-India app which links with the AgroDSS platform and brings the benefit of India's AgroDSS platform to the farmers in the country, right? Now, the context of the work that I would like to describe in the next 5 minutes is this. So, as we were commencing our collaboration in 2022 with the IMD, one of the requirements that again, let me pause there for a minute. Let me quickly explain to you a bit of how the Meghdut app works, right? So this is the Meghdut app. It's available for all the 650 districts in India in over 12 languages, right? So if you are a farmer, and say you are a farmer, say from the Rangareddy district in Hyderabad, so there will be a drop down where you can select the Rangareddy district. So for Rangareddy district, you will see what is the weather recorded at 8 a.m. in the morning. That comes from IMD's automated weather station network. So they have a separate database where all the AWS network in the country is wired into that. So the Meghdut platform pulls the observed weather data from that database, then it pulls the forecast weather from a different database. So together, IMD has a number of different systems, and they also have this new system called AgroDSS, into which all the AMFUs were uploading their crop and district specific advisories, right? So what the Meghdut app does is it integrates data from these different databases and different systems that IMD has, and then presents this, giving the farmer a unified view, right? Now, the context of our project is in 2022, when we were commencing our collaboration, IMD posed a challenge saying that right now, the AMFUs, which are staffed with people, basically agronomists or extensionists, they were looking at the weather forecast for a given district, and then based on the weather forecast, they were also generating crop specific advisory. They asked, is there a way to sort of automate this process? Like, rather than AMFUs manually coming and generating their advisories, is there some machine learning or some kind of a technology which can also take weather forecast and weather data as an input and automatically generate crop specific advisories, right? So we took that as a challenge, and we initially piloted this experiment for about 4 districts in India, for Parbhani, Hisar, Sirsa, and Ludhiana, and did it for 2 crops, rice and wheat. So the way we did it was, the AgroDSS platform, which contains the district and crop specific advisories, was operational since 2019. So we took all the advisories that were issued by these 4 AMFUs for these 2 crops from 2019 all the way until 2023. We divided that. So that is sort of the dependent variable. The independent variable would have been the weather forecast for that particular district and the observed weather for the previous 1 week for that particular district. So you have a dependent variable and you have a set of independent variables, right? And then we also then basically divided the entire data into some training data set and some validation data sets. And then this is sort of how, so we built a machine learning model. So as you can see, now the dependent variable here is basically an advisory, which is basically a text, right? And essentially machine learning does not really understand text. You need to do what is called as a label encoding. so that you take a text and convert that into some kind of a number, which a model can then be trained on. Because between 2019 and 2023, advisories were issued twice a week. So cumulatively, we didn't have a lot of data to train that model on. So when you have a limited number of data sets, the best machine learning model that you could use is something called as a naive-Bayesian classifier model. So we used that model, we trained the model, and then now once the model is trained, the model output again is basically a number which needs to then translate into some kind of a text, because end of the day, what we are trying to generate is a text-based advisory, which can then be disseminated to the farmer, right? So this is where we started integrating the model output with OpenAI for generating the advisories, right? And then what we also did on 10th of March 2023, we tried to compare the output from our model plus AI with what actually the AMFU generated in one of those districts. The results were very, very encouraging. As you can see, if you look at the crop advisory, I won't name the district, but for one of the districts on 10th of March, this is what IMD issued. It is a very simple advisory without containing much detail, but our naive Bayesian classifier, which basically was based on all the training data from the past, it gave a slightly more comprehensive advisory. It didn't stop with asking the farmers to maintain sufficient moisture, but it also said, if your moisture goes down, there is a likelihood of a brown plant hopper disease in your paddy field. It also came up with some recommendation. But then when we did a RAG integration with OpenAI, the OpenAI made this advisory into something much more comprehensive. Not only did it pick brown plant hopper, but it also described brown plant hopper a bit, and it also gave some safeguards about what farmers should do in order to protect against brown plant hopper. Because the OpenAI itself is benefiting from the training it has got from the millions of documents that the OpenAI has been trained from in the past, right? Similarly, in the same advisory, there was something called as a weather summary. Like if you go to the Meghdoot app, it also contains a small weather summary. And when we compared what IMD had given, it didn't give like an actual weather summary, whereas OpenAI gave a much more nicer weather summary for the farmer. Then end of the day, a lot of this content that we create has to also be summarized into 256 characters, so that the gist of this can then be disseminated to the farmers as text. And unfortunately, the guys at the AMFUs never even gave a version of of this advisory, which can go as an SMS. But this is where ChatGPT was able to use some of its language capabilities and generate a 256 character, which could then easily be disseminated in the form of text message. So the results have been very, very encouraging. But for us, the quick learnings are this. Large language models are great, but I think you all are aware, but they still lack the ability to do computations, and hence can be handicapped in their use as decision support systems, right? So the big learning for us is this is where you need AI or ML models or other simple models. These could be heuristic models, or these could be simple crop calendar models even, right? Which have climate and weather triggers, which could then be used to generate decision outputs. And when you have this decision outputs, you try and integrate them with large language models so that it becomes a comprehensive advisory, which can then be communicated to the farmer users, right? And in this context, I think the utility of large language models, language skills, especially at translation, or taking the same content and setting that up as a question and answer setup, so that farmers are more intuitively engaged in the process of advisory dissemination, text summarization. I think these are some very exciting features of large language models, which are also relevant for agriculture extension, right? Yeah, and last but not the least, I think my personal learning from this is, when you think of AI, ML or large language models, a lot of times the impact is not just about creating farmer-facing interactions directly. Sometimes it could also be about rewiring traditional extension systems to actually improve their efficiency and improve the quality of their content, right? So these are my quick learnings and conclusions. Thanks a lot once again. Back to you, Sam.
Thank you, Ram, for the very interesting presentation. So at this point, if you have any questions from the audience specifically on this work, please put them into the chat, or else you can raise your hand if you wish to ask a question in person. And of course, as I mentioned at the end, we will be having a discussion between the speakers specifically on this topic, and everybody can participate during that one here. Okay, so if there are no questions, and I'm sure Ram will be able to take them into the chat, we can pass directly to you, Sheetal. So welcome to the webinar. Are you able to present your presentation?
Thanks, Sam. I just want to confirm if everybody is able to see my presentation and also listen to me.
Yep, we can see you and hear you just fine.
Okay, thank you. So a very warm welcome to this webinar, everyone, and thanks for joining us from all around the world. And I will be talking about unlocking the potential of data, case study of public-private partnership through data-driven innovation. And here I'll be presenting a use case of RCM, which is Rice Crop Manager, and FarmRise, which is a Bayer crop science app, and how we develop an interoperable model in India. I'm presenting on behalf of my team, and also Nagaraj from Bayer has joined us from Bayer side. So my friend Ram was presenting about upstream work that we have been taking in the Digital Innovation Initiative, where Ram is working to develop customized weather-informed advisories. What I will talk more is about the downstream part of extension and how we can make it more effective. First, I'll talk about some of the challenges that we face, especially if we talk about Southeast Asia and South Asia. So the rice growing environment in these areas, they are quite variable, and they vary from small distances, not only with respect to the soil, but also how the farmers are managing their farms. The farmers also have variable access to resources, inputs, and technologies. However, we need to take care of this variability. There is a need to look at solutions which can help us with that. And the good thing or the opportunity is that there are science-based solutions which are available. Site-specific nutrient management principles have been developed through multi-location research trials in ED in collaboration with the national partners. And it provides an actionable, relevant, tangible guidance to the farmers. In addition to that, we now have digital technologies which can help us to take these principles or scientific outcomes to the farmers. And the partnerships, the international partnerships, national partnerships that are coming up, especially with public-private partnerships, help to develop, incubate, and also scale these technologies, and thus take the scientific principles, scientific outcomes to the end users. So there are a lot of examples of underutilized data sets in agriculture. And a lot of institutions, organizations are collecting a number of data sets, whether it's weather data, Ram talked about it, soil health data, machine equipment data, crop yield data, etc. But these data are there, and data is expensive. It takes a lot of efforts, resources, and time to collect those data sets. So the idea is how we can make better use of these data sets. Rice Crop Manager is a ICT-based tool, which is based on the principles of site-specific nutrient management. And it can be used by extension agents or intermediaries to provide field-specific crop and nutrient management recommendations to the farmers. It provides information on the right time, right sources, right amount of fertilizers to match the demand and supply of the crop. And it is also can be customized and has been customized to provide fertilizer information for drought and submergence conditions given the era in which we are living and where climate change is playing a big role. So this particular tool is customized for different countries, including Bangladesh, Indonesia, Philippines, and in case of India, it has been customized for 3 states of India, Bihar, UP, and Odisha. And it provides a recommendation as in a recommendation page where it gives the growth stages of your crop. It gives customized advisory on the crop management, weed management, which is different for direct seeded rice and different for puddled rice. And it also provides fertilizer recommendation. As we scaled Rice Crop Manager, a lot of data sets are being collected because to generate a recommendation, we take the interview of the farmers. So we are collecting a lot of information in Rice Crop Manager backend data sets on the farming practices that the farmers are following, what kind of varieties they are using, what kind of irrigation they are using, how they are managing their residues, etc. Thus, there is a big opportunity of using artificial intelligence for in this backend data sets to estimate the yield. Now, why we need to estimate the yield? This Rice Crop Manager is based on the principles of site-specific nutrient management, which is a yield-based approach to give a fertilizer recommendation. So if a field is producing 1 ton of a rice crop, the demand will be different than a field which is producing 6 tons of rice crop. So the yield-based approach helps to adjust the fertilizers based on the demand of the crop rather than demand of the soil. So currently we are looking at these backend data sets that have been collected over the period of time to kind of, and using AI to come up with a model which can already predict the rice yields without getting the direct estimation from the farmer or, basing our recommendation on what the farmer remembers from the last season. We have been able to scale RCM in Philippines and in India through different partners. And in Philippines, mainly through the Department of Agriculture. We've already generated around more than 2.9 million RCM recommendations. So you can already see the kind of backend data set that has been generated with RCM. So all these profile of the farmers are a part of this backend data set. And with the use of RCM recommendations, when we monitored the fields, we found that the farmers were able to get a higher income of more than USD 200, but also yield increase of 0.1 to 1 ton per hectare. This increase in the income was either due to increase in yield or in saving of fertilizer or a combination of both. Coming to India, where we are scaling RCM in 3 states of India, we've already reached 0.3 million RCM recommendation. This scaling started much later than in the Philippines, and we are working with different partners to scale RCM. And one of the key partners here was Bayer Crop Science, where they have their own app, which is called FarmRise app. And they were providing better crop management recommendations to the farmers. Now, the idea came up, like, if we can use the work that we are doing in RCM of providing site-specific nutrient management recommendation through the Bayer FarmRise app, it will help to bring more customized recommendations for the farmers. And that's where ILRI and Bayer started to think like how we can combine the benefits of this data-rich RCM and their current FarmRise app, bringing it together for the benefit of the farmers. So Bayer FarmRise app, it is an advisory app. It's available in 9 different languages. And the farmers who are associated with Bayer, they get this advisory. It's free of cost app for them. And the advisory is in the range of like, it's not only crop management advisory, but also markets, the products, etc. are available on their app. So how we worked with Bayer was that we started to develop a model or generate APIs which can link both FarmRise and RCM together. And then we did a user testing of the FarmRise app with the farmers along with Bayer crop science. Then the model which was developed was refined, and then it was released as a final version. This final version was then disseminated. The recommendations were disseminated in both UP and Odisha. And we also went back and collected a feedback survey from the farmers to whom we reached out using this interoperable model. These are some of the glimpses of the user testing which was done with Bayer, and how the advisories were disseminated to the farmers. So the user testing was done with the prototype, and then the feedback from the prototype was incorporated into this model. And then we scaled the final version to the farmers. So in UP, it's only a year-old interoperable model. And in UP, we have been able to reach around 10K farmers through the FarmRise app. And in Odisha, we are around at 2,000 farmers. We also got feedback from the farmers who were using the FarmRise app before, and after integration of RCM, what benefits they could get. So the feedback was really encouraging from the farmers, and the farmers were happy that the recommendation now were customized to their fields. So, and they didn't need to kind of do any other calculation for fertilizer recommendation. And they knew, like, if it's a direct seeded crop, how much fertilizer they will need. If it's a puddled transplanted crop, the recommendation will be different. And also it was catered for their varieties. These are some of the initial results that we were able to capture only for this interoperable model. And what we found was there was an additional benefit of INR 12K to 14K per hectare per season. We also used sector tools to calculate the greenhouse gas emissions, to estimate the greenhouse gas emissions in these farmers' field. And we found that the overall global warming potential could be reduced by 8 to 12% just with the change in fertilizer management practices. And we also saw that there was an improvement in crop yield, optimum balanced nutrient use, efficient pest and disease management, and overall optimized crop calendar, that the farmers were more confident on the crop management that they were doing. I think that's all what I wanted to share, but we also have Nagaraj from Bayer on this call, and it will be good if he can add a couple of words from his side. But the main idea of sharing this is that how, if what advantage this model brings when public and private companies, they come together. So it's not just the commercial angle of the private companies, but then how we can bring the benefit of the research that has been done by the public sector or research institute, and how it can be taken more effectively to the farmers. I'll stop here. Nagaraj, would you like to come in?
Yeah. Thanks, Sheetal, for that introduction. And yeah, so you have summarized that. So whatever I wanted to tell, it's almost summarized. So I'll just quickly take a minute to just summarize from my end. So FarmRise and ILRI collaborated somewhere in the end of 2022, and that is when we started working with them to check the feasibility and effectiveness of this particular feature in collaboration with ILRI. And we launched this in Kharif 2023 with 10,000 farmers, both in Odisha and UP, and we are 1 year old now. And post the launch, what we also did was we surveyed the farmers in terms of how did it really help them in terms of using our advisory. So what we found was around 78% of the users told us that they got an yield increase of 10 to 12%. So through this, what FarmRise wants to address is the imbalance in the fertilizer usage by the farmers, which is now currently helping them in reducing the overall cost of their inputs, also increasing the net yield. So we are thankful to ILRI for this collaborative NDBR, and empowering farmers with such tailor-made solutions, which are easy accessible and with the holistic solutions, will continue to be Bayer's priority here. And we hope our FarmRise platform will deliver these kind of commitments to further enhance the farmer experience in consuming the agriculture knowledge and practices. Yeah, thank you.
Thank you so much, Nagraj, and over to you, Sam.
Thank you, Sheetal and Nagraj. It's really great to hear two examples which are really putting these technologies in farmers' hands already at such scale. So before we go to the next presentation, we have a few questions coming in. Please remember to put any questions for Sheetal and Ram, who have presented so far in the chat. So Ram, I don't know if you can see in the chat here a question which has just come in from Ghislaine in Cameroon. And their question is that they have the National Observatory of Climate Change, who are producing and publishing weather data, and every 6 months they're producing an agricultural calendar. However, the estimations are not always correct because of climate variability. For example, they are scheduling sowing activities, but there's not yet any rain. However, they do have a 10-day weather forecast. So the idea would be to incorporate this. So the question here is, what are the tools and other activities that we can use to solve this problem in this specific use case of Cameroon?
So if I have to reinterpret the question is that weather forecasts are probabilistic, and a lot of times there will be a forecast and it need not, what really happens need not agree with the forecast. Then how do you sort of solve this problem? Because I couldn't read that.
I think in this case, it's not that the weathercast is inaccurate, it's because the agricultural advisories, they're given every 6 months. And so they aren't based on the accurate weather information, which is, more real time, I guess, in that sense.
Okay. Okay. Can Sheetal go first? I will read the question. I just found it now from Ghislaine. Maybe Sheetal, you can pose the question to Sheetal and I'll come back.
Okay. Well, if you want, why don't you go for the questions and then we can come back after presenting Eliot Jones. So we have 2 for you. I'm sure some questions will come in for Sheetal as well. And so
okay, I just managed to read it. Can I sort of quickly react to this?
Go ahead.
Yeah, so absolutely right, Ghislaine. Like weather forecasts are always probabilistic. Well, they have their own uses. I mean, it need not be 100% accurate. That's where I think you see when you are coming up with an approach of translating weather input or crop calendar input and then sort of creating something useful to the farmer for decision making, I think you need a healthy blend of scientific approaches vis-a-vis a lot of the AI and ML approaches as well, right? Like for instance, to give you an example, this is what at least we did in our ISAT project. We were you might forecast that it's going to rain 10 millimeter, or you might forecast whether it's going to rain 12 millimeter. Now, whether it's going to rain 10 millimeter or 12 millimeter shouldn't actually bother us. What we should be asking is, okay, if a farmer is planning to go for a sowing operation, what is the threshold, right? It's 8 millimeter or 9 millimeter. Now try and understand the probability that there is also something called as a skill of a forecast. So that's where if you go into climatology and meteorology, there are these concepts called skill of the forecast. So you basically look at the skill of the forecast and translate that into some sort of a quantitative measure, which helps you sort of come up with advisories. I know it's a slightly kind of a complicated answer I'm giving, but you're absolutely right. Forecasts are always probabilistic. There are some established ways where you still take a probabilistic forecast and try to create something that de-risks the farmer. Again, the objective of these advisories is not to, help the farmer achieve the maximum yield. The objective is to de-risk the farmer, protect the farmer from a complete crop loss. I hope I've sort of answered your question.
Okay, well, I saw some hands clapping from Ghislaine there, so hopefully. So there was a second question. I know it's coming very fast, Ram. This one is coming from Danielle, who's asking about the latest releases of OpenAI. which now have gone beyond just interaction via text, and they have capabilities to analyze and process audio without necessarily translating into text. So the question here is, how do you see that affecting the interaction that we have with farmers and extension agents between themselves and in human language forms?
Sure. See, all these are great advancements in the realm of, the human-computer interaction, right? So right now, there is this whole discipline of user experience where you are investigating how best to kind of convey all the information you want to convey to the farmer, right? So I think the GPT-4 probably is a huge milestone in that space. But the fundamental problem of bringing good quality content that is contextually relevant, I think that is still a part of the puzzle that needs to be cracked. Maybe Jau has an opinion on this.
Yeah, if I may add, yeah, it's too bad Eliot couldn't join today. But in his experience in Uganda, the local language, what we found is that these kind of tools that globally used and freely available tools out there are really not good enough to translate local languages. Even if when they say they do have model for local languages, when we tested that performance in local setting, especially in really fast speaking, a lot of background noises, and trying to use that in real setting, the performance was not really good. So there's still a lot of training data should be collected, a lot of benchmarking and performance improvement needs to be done, and a lot of research really needed how we can make it more accurate and fast enough so that we can make it really useful tool on top of it.
Oh, thank you. And actually, can I ask another question?
Yes.
Now that Jau is here. So what about the capacity of local extensionists to understand and effectively use the information provided by this type of systems, or the tools, or the system that you just mentioned in Uganda? Like, what is the training of the support mechanism? Are training or mechanism support in place that can help the extension agents?
Yeah, I mean, Daniel, you've been working on this for quite some time, so you probably know this more than
I'm obsessed about it.
Yeah, exactly. So I think as the tools advance more, as like nobody needed training for ChatGPT, we just instinctively, intuitively already knew how to use it by talking to it. So I think as tools more advanced, and as the more human-centered designs are approached, and as we adopt more feedback into the loop, I think we will probably have less resources needed to train extension agent to use these new tools. But what's needed is to, as Ram just kind of indicated, to understand what the background science went into that, and understanding how to interpret those informations and translate that into actionable knowledge. I think there are still a lot of lessons to learn from like medical sector and health sector, but translate science and knowledge, a very complex science, into actionable knowledge, very easy to understand and also easy to make money out of it. I think there are still a lot of kind of behavior science and kind of maybe interface design, and human-centered design really is needed before we develop this training material for extension agent.
Thank
you, Joe, and everybody. So that last question sets us quite for the next presentation. So unfortunately, Eliot Jones cannot be with us in person, but he shared with us a recording of a presentation which he would have given, which is specifically into this issue of interpreting spoken words in different languages. So let me just check I'm sharing so that you can actually hear it. Yeah, that's going to work. So yeah, we're going to hear from this presentation right here.
My name is Eliot Jones-Garcia. Thank you to AgriLinks for having me. Sorry about the delay in starting my presentation. Today I'm going to be talking about a project conducted by my colleague Nelson Maganga and I and luckily Nelson will be joining later for the Q&A. The project has been conducted as part of the CGIAR Initiative for Digital Innovation in collaboration with Farm Radio International, or FRI. I will be sharing some reflections on our design of an automated speech recognition tool for low resource languages and Bantu languages, which we have named LONGA, or Let's Talk in Swahili. Farm Radio International is an NGO which hosts talk radio programs in sub-Saharan Africa. They work on the principle that farmers have a lot to say, that in sharing knowledge, farmers should also have a voice, and that radio is a pragmatic tool for doing so. We sought to find out if we could support them in this endeavour through the use of AI. The collaboration began in 2021. The first year was largely scoping and sensitization, in which we got to know each other and what forms of software were available. This resulted in a proof of concept of the tool that would become LONGA. Then the last year, which will be the topic of this presentation, has been an effort to make this concept a reality. We are happy to say we are now at a stage where we are field testing the model, and despite some ongoing technical challenges, hope to be handing this tool over to FRI this year. So to give some context, we were introduced to Farm Radio to help figure out what to do with a huge backlog of audio files they have of farmers asking questions. Their existing workflow begins with radio broadcasts, which reach 61 million farmers in 38 different countries. These radio shows are a combination of a drama, which curates effective agricultural techniques, and a question and answer session with a local expert. In a single project in 2022, Farm Radio received nearly 10,000 voice messages from farmers in 5 different languages, 30% of whom were women. To give perspective of how much data they collect, there are currently over 33 active projects. This is where we come in. Farm Radio do not nearly have the capacity to make sense of this volume of calls, let alone the diversity of languages. I think one employee estimated that they would read between 3 and 5%. LONGA is thus intended to transcribe, translate, and better understand each call. This is a real-world example here, with the farmer suggesting that the fertilizer is too expensive and it should be cheaper. The existing Farm Radio management tool, ULISA, will then receive and interface transcripts and key findings, e.g. 75% of the farmers agree that fertilizer is too expensive. The information is passed on to the monitoring and evaluation team, who design radio programs centered around farmer needs, for example, perhaps educating farmers on cheaper alternatives to fertilizer. Programs are written in collaboration with over 1,300 radio stations, tailoring content and expert guests to listener demand at various scales. Providing they have access to radio, which remains one of the most effective and trusted methods of extension across Africa, in particular when access to smartphones remains restricted, farmers will gain access to expert knowledge to improve their livelihoods whilst delivering sustainability. And at the same time, researchers gain access to a vast amount of qualitative data with insights into the lived experiences, challenges, and needs of farmers. Now, at the end of our second year, we have iteratively devised a series of design principles to give shape to and evaluate our work. From the beginning, we wanted to make something that was collaborative, that was based on the needs, values, and expertise of actors throughout the FRI value chain. This means that both parties were going to benefit from the collaboration. We were not going to hand over a shiny tool, and FRI were not going to simply share their data. This involved extensive interaction with FRI and their stakeholders, building rapport and getting a good understanding of their challenges and opportunities. The image here demonstrates Nelson at a meeting this summer in Uganda with FRI and one of their local radio station partners. We wanted the tool to be centered around the challenges of these users and discovered we needed a tool capable of transcribing, translating, and delivering actionable insight from Luganda, one of the major languages spoken in Uganda. We had started the project thinking we would be dealing with Swahili, a low resource language with limited data upon which to build and train a model, and one that is morphologically complex, as demonstrated in this image, is constructed from different morphemes, unlike most European high resource languages, and thus a challenge for conventional language processing approaches. Then with Luganda, this gets even more complicated, as much of the meaning is derived from intonation. As we discovered this, when several local Luganda speakers yielded very different interpretations of a single call during our visit. It was essential the tool would eventually be handed off to FRI for independent use. FRI were concerned that they would be later lose access or become reliant on our support. To solve each of these issues, we decided we would need to use open access corpora, notably the Mozilla Common Voice data, and build on open source models, drawing from Hugging Face and this 2023 publication by Chains et al. A timely publication which has allowed us to utilize cutting edge research and will hopefully allow FRI technicians to update the tool as and when they need it. The final tool would need to be sufficiently robust to be trained on real-world data to satisfy a real-world use case. To do so, we began by training on the Mozilla data for Swahili, thanks to our colleague, other presenter Rebecca for this, which is a relatively higher resource language, to transfer knowledge gained from this dataset onto a dataset from Makerere University, which contains a selection of radio samples of Luganda speakers, which we sourced to better resemble the FRI farmer phone calls. And we decided on a conformer model inspired by Coup 2021, which is better suited to morphologically complex languages due to its ability to capture both local and global context, focusing on summaries of important information, allowing it to generalize and increase performance. We needed to find a way for LONGA to be expanded into new languages without requiring significant input of the end user, and to deal with issues such as code switching or changing languages mid-sentence and low quality or noisy phone calls. We found that fine-tuning was an effective method, running labeled FRI data through pre-trained models to achieve competitive results. In the final model, we intend to employ toolkits which should make operating LONGA accessible to users beyond the AI community, in particular NEMO, which, as pictured here, which means users without advanced programming expertise can tune the model to new data simply by adjusting a few lines of code. We wanted to utilize state-of-the-art technology, enhancing the FRI workflow whilst contributing to the broader AI community. On the one hand, we had great success. By tweaking and fine-tuning, we achieved a 10% increase in the word error rate of the conformer model on the Makerere dataset. On the other, we have faced ongoing challenges in using FRI data, which, unlike the Makerere dataset, is not optimized for this task, and we are now exploring tools to deal with the inconsistency and variety in length and content of farmer calls. Then, moving on to our final principle, the tool is intended to expand the number of female and youth voices in agricultural concerns. We have demonstrated throughout that there is a future for these tools. The focus of this next year of work will then be to scale up and ensure the impact. We want to see downstream analyses that are much easier to do, to inform the design of radio programs, and to expand FRI's capacity to add further languages to LONGA. To do so, we hope to address technical challenges through further pre-processing, and we'll be going back to our collaborators and the community of Luganda speakers to workshop a series of analyses to interface the model output. Thank you very much for listening. I hope you enjoyed my presentation. And I look.
Okay, so that was the example from Eliot Jones. So we've heard just 3 examples from the work taking place in the CGIAR Digital Innovation Initiative, showing that AI tools can already have a real-world impact for farmers at a large scale, and also dealing with some of the frontier issues facing these AI applications. So we have just 5 minutes left up to the hour, so I would like to invite Jay Ruku, who leads the Digital Innovation Initiative, to provide some overall remarks and maybe provoke some questions.
Yeah, so yeah, thanks for this. Yeah, because we only have a few minutes left. Yeah, I had some prepared Q&A before the event, but let me just give a couple of remarks on not going through everything. So I remember one of the things really struck me last year, Ram. Ram and Star, when you organized the event in India, New Delhi, with stakeholders. So we talked a lot about these potential technologies and the AI solutions and what kind of interoperability and data stack we needed in a lot of these technologies. And then there was a farmer or somebody representing farmers, farm producer organization actually mentioned something that you guys are all talking about ABC, AI, blockchain, and cloud. But what we farmers are only talking about and what we are only concerned about is MMM, money, money, money. Show me what makes me money. Show me what can provide profitability in all this. I think that's what we are still lacking critically. All these great potential and great pilots, I think we are still not capturing what is really operational, the profit margin in agriculture and how we can make sure all these services are profitable and affordable for farmers. The studies after studies are showing farmers' willingness to pay for any of these services are much lower than operational cost of the service providers. And extension agents are kind of caught in between. They can provide services, they can provide information from these, product and services. But what if the business fails? What if the performance gets sacrificed because of the operational cost getting higher and higher? So I think we are still quite in nascent kind of stage of this sector, and a lot of research is needed, and that's where our role is. So I think we have to listen to farmers, connect to extension agent, and just see what are the really pain point and how we can scale really beyond the pilot. I think that's where we really need to work together. I just wanted to leave with that. And if there is any question, Sam, are there any other questions on the chat we can discuss maybe?
I don't see any more in the chat coming in. And of course, we will be sharing the webinar recording with everybody who registered. So hopefully there'll be some opportunities for some interactions there. Any further comments on what Jay would just said and of the overall experience from yourselves, Ram and Sheetal?
Yeah, maybe just to add what Zhao said, Zhao, you have really nicely captured like where we are, and there's a lot that we need to do. I think, but these pilots give us a starting point, so these pilots, learning from these pilots help us to understand like what we are doing correctly, what we are not doing correctly, and how we kind of need to modify our pathways, our strategy to move further. So these pilots are good, but as you mentioned, there is a lot that needs to be done. And finally, that should match to the demands of our end users, which is farmers. But I also feel that the extension agents are also our end users, because they are the last leg who are reaching out to the farmers finally.
Yeah, maybe I can also quickly add. I think, yeah, absolutely, Jao, you're right. Like we take a techno optimistic approach to things, right? Like we assume you introduce a technology, the magic will happen. But the magic can happen provided there are so many other things that are also in place. I totally agree with you. We should ultimately aim for the economic prosperity of the farmer. But in the context of the agro-met advisory services, there was a report by National Council for Applied Economic Research in India, NCAER, who have actually done very comprehensive research, collected a lot of data, and concluded that every dollar invested in agro-met advisory services in India has translated into manifold income gains for the farmer. So sometimes I think the problems we face is also, it is so hard for us to really attribute cause. I mean, to see the cause and the effect, right? Because we are working in a very complex setup where so many actors, so many things are happening. Sometimes it's very difficult for us to really relate the impact with any intervention, specific interventions we are actually introducing into the system. But having said that, I totally am with you. We have to be more demand driven. We have to sort of take a more product oriented approach towards developing solutions.
Thank you, everybody. So I think that wraps up the webinar quite nicely. Thank you to everybody who joined us today. As I mentioned, we will be sharing the recording of the webinar, and we will also invite you to the next one of the series. So look out for that. So have a good day, everybody. Thank you for the great presentations, and we'll see you for the next one.
Thank you. Thanks. Bye-bye.
Thank you very much.